Good thing. So what does that mean about the 21st derivative and about the 22nd derivative? Or what does that mean about the 19th derivative and the 18th derivative? You got the 19th?
21, I was like,
I'm just saying stuff to mess with your mind, okay? Doesn't mean I'm saying the right stuff. You got one for the 19th derivative?
Okay.
How do you know your calculus teacher is happy with your test grade? It has something to do with concavity.
Smile is concave up.
His smile is concave up, good.
My God, was
You like that one?
wild one.
Dr. Ginger Vitas, he works at Leavenworth Federal Prison, all right? He's a dental specialist.
At prison?
You get 2 concavities for the price of 1. Okay? What's the opposite of concave? Procave.
oh,
I hope get it.
You get it?
You,
Concave. Cons and pros? Pros and cons?
Oh my.
Oh, I get it. Alright, so did you come up with something?
yeah.
Alright, so if the 20th derivative is positive, then what must be true?
For 21 of that is increasing.
So the 21st derivative would be increasing?
Oh.
And the 19th derivative would be
Wow.
So if the 20th derivative is positive, that means the previous one is what? Increasing, not the next one, right? Okay, so here we would have to say the 19th derivative is what? Increasing. And what else could you say? And the 18th derivative is concave. Beautiful, okay? How about for the next one? If the 9th derivative is concave up, what 2 things can you say? The 10th derivative is increasing.
The 11th is
And the 11th derivative is positive or greater than 0 is another way of saying that, right? I just put is positive because that's how they run it here. Oh. Stop moving things with your eyes, Anthony. Please. Go and carry on me. Good? Got it? Alright. So now let's go to the calculator and do a little exploration there.
Oh, when you put that, if you want to that part, the first part here.
Could it come out on the YouTube video?
Okay? So go ahead and go to your calculator and I want you to type in this function under the graph app. I want you to type in the graph of this derivative. Okay? So open up a graph page and type in this equation. 2x minus x sine of 2x. Open up a brand new page and I want you to type it in on your own even though it's already there. No. It's because I have more than 30 kids, so now I have to put out extra calculators. Is there anyone that doesn't have one? No, we're good? Only 31 today?
Yeah.
So when you press enter, what happens, Robert? Nothing comes out, okay? So check, are you in radians?
Yes.
Does it say rad?
Yeah.
Yes? Okay, so what do you think could be the problem?
You.
Zoom out? Before we zoom out, I'm going to check my equation. So I'm going to press tab again and go up. And what does it look like it's missing between the x and the sign? A multiplication symbol, okay? So I did this on purpose so you can see and not assume that just by entering the equation, it's going to pick it up as multiplication. It does pick it up between a number and a letter, but for some reason, right there, it doesn't. I need to call the people from TI to see what the deal is. But yeah, so make sure you put a time symbol there And now it should work out.
Is it supposed to do it by itself?
It should. I don't know why it's not doing it.
Ah. Look.
Cool. And that's what it should look like. Is that what yours look like? Now it does say to adjust the window, right? It says to only draw it from where to where? -5 to 5. So how can I adjust my window? Menu, 4, 1, window settings, right? We want to go from -5 to what? 5. We're working with trig, so I don't want to go by ones for my scale. I want to go by some radian measure. What do you want to go by?
The window.
What's a radian angle, a small radian angle that we could use as an interval? Pi fourths? You want to go by pi fourths? Okay, so right there under x scale, change it to pi divided by 4.
Figure out how to do pi. Why not?
The pi is at the bottom, next to the 8. How about the y values? Do we leave them like that and just see what happens?
Yeah.
Or you want to change them?
I'm not gonna.
Change them? What do you want to change them to? To 10? Okay, let's try 10. -10 to +10. And those, you want to go by ones?
Sure.
Okay. Can we see the whole graph, or are we missing a little bit of it? Missing a little bit over here, right?
Yeah.
So maybe we gotta go further down from 10. What do you want to go to?
Negative
15.
-15? Alright. 100 is a little bit too much. I think -15 will be good enough.
Do we do the top one too?
The top one, I left it at 10 because I could see what was going on up here. Sounds good? What did I set it as? -15? To 10?
Second block.
Good?
What block?
Alright, so now we can see this derivative graph pretty good. Now let's look at the questions that I have to answer regarding it, okay?
Yeah.
So what does it say here? Based on the graph of the first derivative, how many relative extrema does the graph of the original function have? Alright, so how do I know I have relative extrema on my original function? Where does that occur?
Changes from increasing to decreasing.
What changes from increasing to decreasing?
The original.
The original, but we don't have the original, we have the derivative graph.
So when the initial zero.
Positive.
So when h prime of x, right,
Changes that.
changes from positive to negative or negative to what? Positive. If it does this, then I have a what? I have a max. If it does this, I have a min. What's actually happening if I'm looking at the graph? What's the graph doing? Crossing the x-axis, right? In this case, it would be going from where? Above to below, and over here? Below to above. Do we understand? That's what the graph is actually doing when I'm looking at it on my calculator. So go ahead and look at your calculator and see if anywhere on that graph it goes from above to below or below to above the x-axis. At 0? Right there, right? It's specifically going from where?
Negative to positive.
Below to above, right? So that means I'm going to have a what? Relative min. So let's answer this question. How many relative extrema does h of x have? Okay, so write that down. H of x has 1 relative extrema. And what would it be? A relative min, right? At x equals 0, because
F H prime of x.
h prime of x
Change from negative.
changes from negative to positive. Would it be okay, do you think they'd give me credit if I say, because h prime goes from below the axis to above the axis?
No.
You think they'll give me credit for that on the AP test? No. Okay, that's just something I'm telling you so you can identify it quickly, but that's not a proper justification to write. Okay? You understand? So remember that, right? Same thing like with the limits, when we did the little gummy bears, it's not proper to say that the limit exists because the gummy bears kiss. Okay? You have to say that the limit exists because the limit from the left is equal to the limit from the right. If you weren't in my class, you didn't experience that. They had little gummy bears and they would travel from both sides of the curve. And if the limit existed, they would approach the same value and they would kiss, right? Those are the answers they would put on their test.
So if actually did that, I was like,
Yes, yes. That's why I had to say that. That's not a proper justification, okay?
someone actually put that.
Probably not anyone that continued to the CLEAR did it. I don't remember off the top of my head,
Was it
but I
Axel?
tried to oppress those memories. Alright, number 2. Based on the graph of the first derivative, how many points of inflection does the original graph have? How do I find points of inflection if I have the first derivative graph?
Relative max or
So I'm gonna have a point of inflection if the first derivative has a what? Relative maximum or what? Relative minimum, right?
Yeah.
So points of inflection occur where h prime of x has relative extremum. I don't know, does it? It only has one?
Yeah, but you keep biting it like.
Oh, I'm gonna write, it's a big M.
Like the iron.
Oh, it's not one, no, it's one,
The
two,
iron.
three.
No, they're talking about the M.
Yeah.
This is each.
Extremum.
Actual word.
Good.
Yes.
So, it's wherever the first derivative has relative extrema.
It has.
So, how many relative extrema does this first derivative graph have? Only one? It only has one max or one min?
No, it
No,
has
no, no,
one,
no,
two, three, four,
1,
five.
2, 3. Is this one?
The point of inflection.
Point of inflection.
Point of inflection.
That's a point of inflection?
No, actually, no, it
It
wouldn't.
has no
No,
concavity.
the point of inflections are where
You
the
can test
maximums and
whether that
minimums
is.
are.
You can test.
We're talking about like the actual.
Yeah, wait, what
how many points it has. not
Two.
how many
What has to
It
happen
has wood.
for me to have a maximum or a minimum? Because that's what we're looking for.
Where's the name?
Oh, it has to change.
It would have to change from what to what?
Negative.
Change sign.
Increasing to
Decrease.
decreasing or decreasing to increasing. So here, is there any change? This is just constantly what? Increasing. So there won't be a max there. Here there's a min because it's decreasing and then
Increase.
increasing, decreasing, decreasing,
Increase.
increasing, 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 decreasing. Good. So how many are there? 1, 2, 3, 4, 5, right? So there's 5. Okay, there's 5 relative max or min on the first derivative graph. Therefore, that means there has to be how many points of inflection on the original graph? 5. So h of x has 5 points of inflection because h prime of x has what? I really zoomed in.
I was like, that 5 is huge.
Has
Very
5
good.
relative
5
extremities.
relative
What was that like?
extrema.
Oh, not
No, I'm gonna start writing.
Wait, does the extrema have one end?
No, look,
The
there's
extrema
3
has one
M's.
end.
Yeah, that's 1 m.
Let's take
Oh my
Made
god.
it kind of big.
Kind of big.
It looks like
Good.
you're writing and you forget the word.
Alright. So now let's prove it. Okay? Let's prove that we truly have 5 points of inflection on the original function using the second derivative. Okay. So I want you to find the equation of the second derivative. Let's see if we remember how to find the derivative. 2x minus x sine of 2x. How do I get the derivative of this guy? What's the derivative of 2x?
2
2
minus product.
minus, then we gotta do product rule? Okay, so now this is where it's gonna get interesting, okay? Because I do product rule one way and you guys did product rule another way. Okay, either way works, either way works. When I taught your class, I did it the way you guys did it, just to continue it, but, yeah. Okay.
In my class.
I'm gonna do it the way my
How did they try?
Yeah, how did they?
I feel like cheated now, what
It's
did
the
they
same
do?
thing, it's the same thing. We're just doing it backwards.
Yeah,
So the way we did it is, we did derivative of the first times the second. You guys did the first times the derivative of the second. So I just switched it up.
I did it with them.
The same
I did
thing.
it with you guys.
Okay?
And there,
You won't
the right
panic?
way, that's the-
Alright, so derivative of the first, what's derivative of x? Times the second, sine of 2x. Plus the first, times the derivative of the second. What's the derivative of sine 2x?
Two cosine,
Cosine 2x times
times 2.